In this video, we're going to look at the concept of rate of reaction and average rate of reaction in chemistry, and look at their units, how they are measured, and do some calculations on paperwise. So let's look at rate of reaction. Now, in chemistry, rate of reaction is basically calculated using this formula: change in concentration, alright, over change in time. Change in concentration is use unit is mole per length, whereas change in time each unit is seconds. So we bring everything together. The unit of rate of reaction will be mole per length per seconds. Alright, so this will be the unit of rate of reaction. Okay, let's say we are given this expression: reactant A give product B. So using the formula or expression above, to get the rate of reaction is going to be change in reactant A over change in time equals change in product B over change in time. Alright, so meaning that reactant A, the change is equal to change in product B with time. Alright, so note that this negative sign here signifies that the reactant will disappear, whereas this positive sign here signifies that the product is appearing. Alright, okay. Alright, so let's look at reaction rate and stoichiometry, right? That involve stoichiometry coefficients. Let's write this. Okay, let's see, we're given this expression: A plus B, we have to give C plus D. Alright, so the rate of reaction, how to calculate this, the rate of disappearance of A. Just assume that the stoichiometry coefficients, this is the coefficients here, are not equal. So to calculate the rate of disappearance of A, we're going to have it to be, we divide it by the stoichiometry coefficient. So it's going to be, disappearance of A is going to be minus 1 over A, where this A is the stoichiometry coefficient, alright, times the change in the reactant A over change in time, whereas the disappearance of reactant B will still be minus B times change in reactant B over change in time, whereas the appearance of product C will be change in product C over change in time. So this C is the stoichiometric coefficient, and also the appearance of product D will still be plus, this is D, right, change in times change in product D over change in time. Alright, so with this expression we have here, invariably is saying that the disappearance of reactant A, of change in reactant A, alright, with time equals the disappearance of change in reactant B, alright, with respect to time, is also equal to appearance of product C, right, with change in time, alright, is also equal to appearance of product D with respect to time. So this is change, this simplifies change. Alright, So remember, this small letter A, B, C, D represent their stoichiometric coefficients. So we divide it by the stoichiometric coefficients. Alright, so let's wipe this now and look at average rate of reaction. Remember, we're going to solve problem on this. Okay, so average rate of reaction is calculated. This is basically the change in reactant to product concentration over a given time. So let's say we're given this expression, reactant A give the product B. So to calculate the average rate of reactant A is going to be change in A over change in time. Remember, this minus sign signifies that the reactant is disappearing, whereas for the average rate of the product B will be change in product B over change in time. Alright, so this plus sign signifies that it's disappearing. Alright, so which means that it's going to be changing reactant A. Alright, final minus initial, right, over change in time T2 minus T1. Alright, whereas for the product it should be this final minus initial over T2 minus T1. But it's having known these basic formulas for rate of reaction and average rate of reaction respectively. And let's look at problems on this now to understand this formula to apply it to any question asked to solve. Alright, so let's wipe this. Alright, so let's look at this problem. It says the following data was obtained for the decomposition of dinitrogen 5-oxide at 45 degrees centigrade into products. Calculate the average rate of reaction between 400 and 600 seconds. Alright, so remember the average rate of reaction is calculated using change in A. Let's say the reactant here is A over change in time. Alright, so it's going to be, they say between 400 and 600. Alright, so that means our A2 will be under 600 time. We have concentration to be 1.15 rather, so it's going to be 1.15. Alright, this will be our A2 minus our A1 will be under 400. We have 1.28. Alright, put this minus sign because of its reactant is disappearing. Alright, over the time, the T2 will be 600 minus 400. Okay, so remember these are all in mole per length and seconds. So when you simplify this, you're going to have 1.15 minus 1.28. You're going to have minus in brackets minus 0.13. Alright, over 600 minus 4, you're going to have 200. So minus times minus will give us plus. So this is will be 0.13 over 200. Right, because minus times minus will give you plus. So let me point use my calculator. 0.1 divided by 200. So we're going to have the value to be 6.5 times 10 to the power -4. So you input the unit, which is mole per length per second. Right, so this will be the value or the answer to this question. Now we have solved this problem on average rates of reaction. Now let's solve a problem on rates of reaction. This time I will not average rate of reaction. Let's write this. Okay, so look at this question. It says assume that it was observed that during the decomposition reaction, two moles of ammonia decomposed to give nitrogen gas and 3 moles of hydrogen gas, that hydrogen was formed at the rate of 0.062 mole per length per second. So A, calculate the rate of the composition of ammonia at the time. B, calculate the rate of formation of nitrogen gas at the time. And C, calculate the rate of reaction at the time of observation. Alright, so remember the general formula is going to have it to be minus 1 over 2. This 2 is the stoichiometric coefficient of ammonia there, right? Over changing ammonia, right? Over changing time equals, right, that of nitrogen, right? Changing nitrogen over changing time equals changing. So we have 1 over 3 of hydrogen over changing time. So we put plus here, showing that it appears in the products. This one minus signifies that ammonia disappeared. Alright, now since we are giving our rate of formation of hydrogen in the question to be, so rate of formation of hydrogen, we have it to be that's changing hydrogen, right, gas over changing time. We have it to be 0.062 mole per length per second. Now to get the rate of the composition of ammonia at the time observed, since we are given the rate of appearance of hydrogen, remember that of ammonia disappeared, alright? The composition there disappeared, right? So to get that of ammonia and we are given the appearance of hydrogen, what we are going to do is that we write the terms of hydrogen, alright? We write the reaction involving hydrogen and ammonia, since the rate of ammonia decomposition will be calculated from the rate of formation of hydrogen. Well, let me show you. It will be rate of disappearance of ammonia equals rate of appearance of hydrogen, alright, over dt. Alright, remember this we have plus here. So now to make ammonia, rate of disappearance of ammonia, the subject formula. Alright, so we are going to divide both sides by minus 1 over 2. So this will cancel this. We now have, let me wipe this side. So it will be when you make the ammonia the solid formula, it will now be, we're going to have the changing ammonia, rate of change of ammonia to be 1 over 3, alright, rate of change in hydrogen over with respect to time times minus 2 over 1. Alright, so when you simplify what is here, this minus 1 over 2 will be inverted to minus 2 over 1. Alright, so when you simplify further, you're going to have, you now impute the rates of formation of hydrogen in the value we have it to be 0.062. so it's going to give us, alright, let me write it, it's going to give us 1 over 3 times, alright, 0.062, alright, times minus 2 over 1. So when you simplify everything, they are going to have 0.062 times minus 2. So let me put it in my calculator. So you're going to have it to be minus 0.124 divided 3. So the final answer for the rate of decomposition of ammonia will be, so when you punch it in the calculator, you're going to have minus 0.041 Alright, so this will be the value for the rate of decomposition of ammonia. Now, the rate of reaction of decomposition of ammonia will be 0.041 mole per length per time. Now, note that the rate of reaction is always positive. This negative sign here is as a result of the fact that it's disappearing. Alright, so when you're writing your expressing your answer, that put a negative sign, it should be in positive sign. Alright, so this is for ammonia for question A. Now let's solve question B. Calculate the rate of formation of nitrogen gas. So let's write below. Alright, so the rate of formation of nitrogen gas, that will be appearance of nitrogen gas, the rate of appearance of nitrogen gas equals rate of appearance of, let's also write it or express it using, since we have the value of hydrogen, the rate of formation of hydrogen gas, so we express in terms of hydrogen gas. Also, so the rate of appearance of nitrogen gas will equal rate of appearance of hydrogen gas, right? So when you impute the values, you are going to have it to be for hydrogen gas, so it will be equals 1 over 3 times, so that of hydrogen gas will have it to be 0.062. Alright, so when you simplify this is something as 0.062 divided by 3. So let me divide in my calculator here. So when you divide, you're going to have the value to be 0.02, alright, mole per length per second. Alright, so this will be the rate of formation of nitrogen gas at the time observed. Alright, okay, for question C, calculate the rate of reaction at the time observed. So let's write below. Let me show you what that means. Okay, so the question says once more, calculate the rate of reaction at the time observed. So remember the rate of reaction for our hydrogen. Alright, I have the hydrogen gas to be 0.062, and that of ammonia, we got that of ammonia to be 0.04, right? The unit mole per length per seconds, mole per length per second, and that of nitrogen gas, we got it to be 0.02 mole per length per second. Alright, so to calculate the rate of reaction time observed, alright, so we are going to do it using the disappearance of the reactant or the rate of appearance of the products with the stoichiometry coefficient. Alright, what this means is for hydrogen, for rate of appearance of hydrogen, so it will be 1 over 3, alright, times 0.062. So this is something that's 0.062 divided by 3. So when you simplify this to calculate, you're going to have 0.02. Alright, so if you're leaving it to two decimal places, for that of, remember this 3 is the stoichiometry coefficient of hydrogen gas there, while for that of ammonia, it is, this ammonia will be 1 over, since it's disappearing, it will be minus 1 over 2 times minus 0.04. Alright, so this is the same thing as, so minus times minus will give you plus, so something like 0.04 over 2. So when you punch this to your calculator, you are still going to have 0.02. Alright, if you are leaving it in two decimal places. So as you can see, this 0.02 is the same thing for ammonia, the same thing for hydrogen, also the same thing for nitrogen. So that means the rate of reaction for the decomposition reaction is 0.02 mole per length per second. Alright, so this will be the rate of reaction at the time observed for the decomposition reaction of ammonia to yield nitrogen gas and hydrogen. Alright, so guys, this is basically how you can solve problems involving rate of reaction and average rate of reaction in chemistry. And with this, I've come to the end of the class. Hope you did something interesting. If you're new to the channel, be sure to subscribe for more videos. Those who like, share, and comment on the video, tell me how you feel for what you have learned. If you seem to have any specific questions, feel free to leave your place in the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching.